We're going to wait for this to go. Perfecto. Okay, hello everybody. My name is Dr. Tara Lindhal, and as Nathan just said to you, I'm actually a clinical psychologist, a doctor of psychology. So no, I don't do coding, but I can tell you what you guys are doing when you are coding. Lovely 80s reference for those of us old enough to remember. And I could say any questions and drop the mic and walk off, but we're not going to do that. What we are going to do is first I'm going to review with you guys kind of the basic parts of the brain. And then, more importantly, which parts are relevant to you when you're programming, because that's what we care about, right? And then lastly, how tone may affect the ease or unease of your programming. So, we're going to start with this. Many of you are familiar with the brain, so this is a very beautiful rendering of our brain. I wish it looked like that for real. It's actually kind of spongy and icky. People are familiar with I'm left-brained, I'm right-brained. Oh, I'm really good at math. I must be left-brained. Oh, I'm very artistic. I must be right-brained, right? Hand dominance tends to go with the side of the brain that you are stronger in. Well, actually, that's a very oversimple version of our brain. So let me brain-splain this to you. This is your brain. Well, not your brain, I hope, because then we're going to have a huge problem. So this is a pretty typical chapter of any book that I had to read when I was in grad school. The pretty colored parts are the cerebrum of your brain. So that's the main part that kind of makes us human. It's actually divided into 4 lobes, and some of you may have heard of the 4 lobes of the brain. So first we have the frontal lobe, right? The frontal lobe is what makes us humans. All living things, all animals have brains, right? Some bigger, some smaller. Our frontal lobe is the key to making us a human being. That is our reasoning. That is our expressive language, so we don't all just bark, right? I'm sitting here speaking to you because I have the ability to use expressive language. It's higher order reasoning. It's my ability to pay attention to this and not any of the conversation that might be going on around me, right? Which also means that if this area of the brain gets injured, you have a mess. So there was a recent movie out called Concussion. Did anybody see that movie? Will Smith? About the doctor from UC Davis who's actually the medical examiner now in San Joaquin County, which is right where we live. That whole movie and concussive syndrome, CTE, is about what happens if you repeatedly hit that frontal lobe of your brain. So what happens? Why do you need to wear a helmet when you're bicycling, right? Why is that so important? It actually will make you not be able to pay attention. It makes you not be able to have that filter that makes you be able to sit in your office and not curse everybody out or table flip every time you get frustrated, right? It also, when people have frontal lobe damage, they take risks of various types. They act out sexually, they act out aggressively, which is kind of some of the things that we saw with some of the football players that did. Junior Seau took his own life because he had this concussive syndrome that made him not be able to actually function and reason. Very, very important part of the brain, and we're going to come back to why that's important to you all later. So the next most important part of the brain for you guys, your temporal lobes, which are, guess what, by your temples. Very apropos, right? So in your temporal lobes, that's receptive language, that's where your hearing is. And it's also where your hippocampus is. And this is where Will or Jed or somebody could put some kind of pun about a hippo on a college campus. I'm not going to do that right now because I suck at it and they're all much better than I am. But your hippocampus is your memory maker. So that's where you solidify all of your memories. So again, if that part is damaged by any kind of disease or anything, you're going to lose your ability to sustain long-term memories. Next, we have your parietal lobe, and that is your, big word here, somatosensory cortex, dun, dun, dun. That's your ability to have tactile sensation. So I feel this because my somatosensory cortex. It doesn't play as much of a large role in coding unless you're doing a lot of head banging against the desk, which I hear is sometimes a problem for y'all, but that's not directly related to coding. And then lastly is your occipital lobe, and that's right kind of here behind your eyeballs because that's sight. That's the area of your brain where your optic nerve connects from your retina to the back of your brain, and that's how you see things. So that's how you're going to look at the code that you're doing, because I hope you're looking at your code. Unless you're using some of Brian's accessible stuff, and then it's talking to you, and that's a whole nother talk. So, Homer, right? One side, this little pea-brained Homer, that's an MRI, just plain. So in a regular MRI, you're just looking at the brain itself to see if the parts are all there, right? That beautiful artist rendering of Homer is a functional MRI. And what we're interested in the functional MRI is what part of the brain is functioning when you're doing a specific activity. So what does this have to do with y'all? These are actual images of fMRIs, functional MRIs. And so what typically happens during a functional MRI, it's based on the fact that when you're using a part of your brain and or a part of your body, blood is flowing to that area. So when you work out a lot, your face gets flushed and your arms get all swollen, it's because that's where the blood is flowing. When you're thinking about something, that's the area of your brain that's activated, the blood flows there. So for a typical fMRI, they'll have somebody do a simple activity. Usually it's looking at a specific type of picture, so it's thought to kind of bring up a memory or an emotion, and then they'll have them do that for 30 seconds and then close their eyes. And they'll see the difference between the blood flow with the eyes open, that mental activity, and the eyes closed when there shouldn't be any of that activity. So the orange spots are obviously where the blood flow is. So let's put this all together in a way that works for this audience. Most of you have heard of STEM education, right? Science, technology, engineering, and math. Wah, 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 wah. Hear it over and over again, over and over again. But what if computer science and programming wasn't just based on these math abilities, but also had a language component? Because it is a coding language, isn't it? It's not called a coding math. So, a computer scientist named Janet Sigmund at the University of Passau was actually interested in this whole language or math debate. So, being that she already worked at a university and had a bunch of freshmen that she could make do an experiment, she did just that. So she took 17 of them, 17 computer science students, and had them sit in an fMRI scanner, which is, has anybody had an MRI? It's basically a tube. And you're sitting in a tube doing this thing, which is confounding in itself because you're sitting in, when are you programming sitting in a tube? I hope none of you do that. It's probably not the best place to code. But she had them sit in a tube and look at source code snippets. Very, very simple, basic source code snippets because, again, these are students and we're trying to get a base level. So when you're thinking about what they were doing, think about just kind of reading back on your code and looking for syntax errors. Very, very basic. So they went into this tube, and she basically had them read different sections of the source code. And everybody kind of had a different section so that she could look at the results and average them out. And also, to make sure that we weren't activating the part of the brain that actually does error searching, because if you're looking for syntax errors in source code, you could be looking at that area and not the actual reading of the code part. She had them do a second task, which was actually just looking for errors in language, regular language, so that we could pull that part out, right? So confounding variables in an experiment. So all of the code consisted of several lines, at the end of which there would be a printout, right? And the student's job after reading the lines was to predict what the printout would be. Very simple. So what happened? Dr. Sigmund actually found that there was a clear and distinct activation pattern in the brain. And what area was activated? The language centers. It actually showed that there was a universal understanding of that those who actually had, you have to have a base level of understanding of coding, right? But when they looked at the code, those areas of the brain that are used for reading and understanding receptive language were what was activated. Interesting, even though there was code that involved mathematical operations and computations and loop iteration, those particular tasks, you would think, hey, those are mathematical and computational, we should probably get that part of the brain activated. But that wasn't so in this task. They actually were not activated at all, and only those language centers were activated. So, what does this mean? Language actually plays a larger role in coding than most might think. Should schools be pushing that as well now? Something to think about. It's also really important to recognize some of the little things that came out of this. When she says that it's more like language, it's not like me, an primary English speaker, learning to speak French. It's more like me reading English, that part of my brain. Because learning to speak a new language has so many different complexities of your brain that come in, and the memory and the learning, the hippocampus and all of that stuff. This is looking at something that's familiar in written language. So, we're going to talk about this in a second. So we just talked about kind of what's going on in your brain. But what a lot of people tend to ask me about when they find out that I'm a psychologist is how they feel. Oh, have you ever felt this? Oh, when I'm sad, I feel like that. And how do you think your emotions might play a role in your ability to code? It actually plays a larger role than you might think. So as I start talking, I'm going to scroll through this a little bit, but I want you to look at the 3 error messages that are up on the screen, and they're going to change. Think about the first one as a neutral error message. Think about the middle one as obviously really freaking negative and frustrating, and the bottom one as something that's positive. And think about what it would be like if you were coding and your compiler gave you these messages and how that would make you feel, and as somebody who's trying to get this project done, and you're under a time crunch. So there was a study that looked at just this. They took 32 participants, and they were told to attempt to correct a series of 5 bugs. Yay, bugs. You guys all love that, right? IE11, it's your favorite, right? I don't even work in the field, and I know all about browser errors. So during their task, they received compiler messages, just like the ones up here, that were specifically latent with keywords that were either very, very negative or very, very positive, to see if that actually would affect their productivity and aspects of their code. And what happened? So there was actually a major difference. Those who received the negative ones, like this wonderful yellow thing, fault destroyed program execution. It's like core dumped. It sounds like the nuclear reactor's melting down, doesn't it, right? It's bad. It's bad. Those who got these wonderful, beautiful messages here actually attempted fewer repeated solutions, and the probability of them continuing to push on through this was significantly different. Significantly different. So it's kind of like when you've been coding for a while and you get that bug that you just can't figure out. And you want to plow through it, and you know you need to plow through it, but at the same time, your computer keeps telling you you're an idiot. Nope, you did it wrong. Nope, you did it wrong. Nope, you did it wrong. Nope, you're wrong, wrong, wrong. Eventually, what are you going to think? I'm an idiot, I'm wrong. And then you're not going to want to do it anymore, right? Just like a kid learning to do a new thing. And I actually had this conversation with somebody last night. If somebody's child was learning to do something, and their parents weren't like, get on your bike and try again, but said, oh, you fell? You suck. Would the kid want to get back on the bike? No, I wouldn't want to get back on the bike. I suck. I'm going to go cry in my room right now. So it actually shows this connection. So what's going on in your brain? Because everybody says, what's going on when that happens? The results actually suggest that in human-computer interactions, messages are a really important factor in the creative problem-solving process. So there's an area of your brain called the limbic system. And the limbic system is a very, very touchy little fellow. If it wasn't for the limbic system, I wouldn't have a job. The limbic system is located at the connection of your temporal lobe, hippocampus, think inside of your temporal lobe, and the back of your frontal lobe, so attention and reasoning. So what happens? You hear something, you feel something, your body shuts down, right? So basically, this system is your emotional nervous system. Our ability to problem solve, our ability to be rational, gets completely cut off when the limbic system takes over and says, alert, alert, alert. It's like the squeaky wheel gets the grease in your brain. So you're getting all these negative messages, or hopefully the positive messages that we saw. And when you get the negative ones, your limbic system says, I suck, and tells the rest of your brain, don't bother. You can't even think your way out of this because I'm too busy crying. Or the other way around. You get a positive message. I'm awesome. I'm so close. Yeah, I didn't get this one right, but I'm right there. You'll keep working through it. It's basic reward and punishment, but you don't even realize that it's going on, right? Pavlov's dogs, reward and punishment. We are still primal beings. So, this is a little snippet about a programming language that many of you have probably heard of called Elm. Elm is great for this reason. They're striving to make sure that these error messages are something that make you motivated to continue to program. They don't want to tell you that you suck. And no, I don't work for Elm. I'm not advertising for Elm. I have no investment in their public offering. But I do appreciate the psychological side because, yeah, you're working with computers, but everybody that I see, unless, there's some Cylons in there I can't see, everybody's a human. And there's a human side to programming. And if you're not satisfied with the end product and you're being told not only from your project manager that things are late and you suck, but you're being told from the project you're creating that it sucks, why are you doing this, right? So Elm is actually striving to make sure that error messages are constructive and give positive feedback along with, hey, you did this wrong, maybe you should look in this direction, which I think is fantastic because I live with a programmer, and it would be nice if I didn't hear the head banging all the time. That's why I know about IE11, because I hear it a lot. I hear, what happened? Don't worry about it, browser error. Oh, all right, sorry. So thank you all for listening to my wonderful talk. This is me in Honduras with my sloth friend. So yeah, thank you.
We are short hair, purple hair twins. Thank you so much, Tara, for your insight, your psychology insight. Love it. Will told me to tell some joke about the hippocampus, and I'm not gonna.
No,
I can't do it.
I said no.
I can't do it. So you can ask Will about it later. It was definitely punny because that's just like.
I told you no. I told you no.
Well, I didn't do it, so it's to be fair.
Oh my God.
Anyway.
But bump.
So let's see. So that was a great talk. I don't have nothing much to add to that. But tell us about your dog, and you had a ceremony for it once. I would love for you to go into that.
She's really doing this to me right now. So I
don't make it ask whatever you want.
I did. I gave you free license. So Derek and I don't have kids, but we have a dog, and we're kind of obsessed with him, kind of like he's a child. And I was raised Jewish, so I might have had a bar mitzvah for him. I might have.
She knitted like a little. I don't know what that scarf is called.
I knitted a yarmulke and a tallis. We all had cake. It was fine. My mom came. She was happy. She finally had a Jewish grandchild. It's fine.
So you might not know is that Derek and Tara helped organize JSConf US, which is awesome. If you guys ever get a chance to go, if they ever do it again, that'd be awesome. So you've been hanging around devs for a long time. What's one thing that's like what the biggest thing that you've learned from working with people like us?
People like us, one of us. That there is no such thing as people like us. I feel like it's such a diverse crowd. Everybody comes in with their own little bit of knowledge and their own little bit of background, and just because you say you're a developer or even a JavaScript developer, that doesn't mean there's no one thing. So I've been working in the field a little bit now. I've been doing some QA, and I've been learning about just even the difference between, like you said, a front-end developer and a back-end developer, and the plight of the server crashing on you versus browser differences, and what you guys really go through for, as I call, a stupid website. And don't take that the wrong way. Don't take that the wrong way.
No, it's totally true.
I spent a lot of my career working with pretty dangerous populations. I worked in prison, and then I worked in a drug and alcohol rehab. So I've stopped people from killing each other. I've stopped people from killing themselves. And I've had some really rough days. I've had poop thrown at me. I've had computers thrown at me. I've been stabbed. I have a scar on my forehead from being attacked. And so I'll come home from some really bad days, and I'm like, bring me a beer. I don't want to talk to anybody. I don't want to do anything. And Derek's like, I had a really bad day, too. And I'm like, oh, really? Oh, the website doesn't work. I'm sorry.
I'll leave it at that. Thank you so much, Tara.